For decades, physicists believed the International Space Station was the beginning of permanent life in space. Now many of us believe it proved the opposite, because the ISS did not show us how easy living in orbit would become. It showed us how fragile it truly is. When the International Space Station was first imagined, it was not meant to be unique. It was meant to be a prototype, a first step toward a future where building structures in orbit would become routine. I believed this for many years. Most physicists did. History encouraged that belief. The first computers filled entire rooms. The first aircraft were unreliable and dangerous, yet refinement followed and progress accelerated. It seemed natural to assume the same would happen in space, but physics does not reward optimism. It rewards accounting. The ISS feels permanent because it has been there for decades. Astronauts float calmly through its modules. Supply ships arrive on schedule. It passes over our heads like a steady moving star. That creates an illusion. The illusion that orbit has become normal. In reality, nothing about the ISS is normal. It exists only because an extraordinary number of conditions aligned at the same moment in history. Political cooperation between former rivals, budgets large enough to tolerate inefficiency, public patience for delays measured not in years, but in decades. Remove any one of those conditions, and the station would never have been built. Even technically, the ISS is far less independent than many people imagine. It does not float freely. Its orbit constantly decays and must be corrected. Its systems age faster than anything on Earth. Every 90 minutes, it moves from intense sunlight into freezing darkness. Radiation slowly damages its electronics. Micrometeoroids strike its surface. Nothing in orbit ever rests. Every second the station must actively fight the environment just to remain alive. This is not a design flaw. It is physics. Then there is the human body. Microgravity weakens bones. It alters vision. It disrupts the immune system. It changes how fluids move inside the brain. We manage these effects. We do not eliminate them. Exercise slows the damage. Medical monitoring tracks it, but no technology has solved it. A permanently inhabited station would require generation after generation of humans to live inside a medical experiment that never ends. That is not scalability. That is endurance. We are often told that modern technology will solve these problems. Reusable rockets, automation, artificial gravity, improved radiation shielding. Each idea sounds convincing on its own, but combined they collide with reality. Radiation shielding requires mass. Mass requires energy. Energy requires launch capacity. Every solution shifts the problem somewhere else. Physics does not allow complexity to simplify itself. It accumulates. On Earth, we build large structures by leaning on a planet-sized life support system. Gravity holds things together. The atmosphere moderates temperature. Repair crews arrive within minutes. In orbit, none of that exists. Every function must be enforced continuously. Air must be scrubbed, water recycled, pressure maintained, orientation stabilized, orbit corrected. There is no steady state where these systems become passive. Entropy never sleeps. Time always works against the structure. The ISS was not difficult because it was the first of its kind. It was difficult because space resists permanence. What made it possible was not efficiency. It was historical coincidence. A narrow window when ambition, resources, and politics align just long enough to make it happen. That window has closed. Building another ISS would not represent progress. It would represent repetition without the justification of discovery. This does not mean humanity is abandoning space. It means we are learning how to listen. Robotic systems do not suffer bone loss. They do not absorb radiation into living tissue. They do not require psychological support. They can operate longer, farther, and more safely than humans in hostile environments. The future of space is not constant occupation. It is intelligent presence. The International Space Station is not a failure. It is a completed chapter. It showed us what is possible and where the limits truly are. Some achievements are meant to be singular, not because we lack imagination, but because the universe has rules, and understanding those rules is how progress actually begins. The International Space Station will not last forever. When it finally leaves orbit, it won't mark the end of human ambition in space. It will mark our understanding of it. The ISS was never a city among the stars. It was a question, and physics has answered. The future of space exploration will not be built on permanence, but on precision, knowing where humans belong and where machines must go instead. Progress is not measured by how long we can survive in space, but by how wisely we listen to the universe. If this perspective resonated with you, consider subscribing. Here, we explore science through evidence, not hype. And as always, keep looking up.